Okay, in this video I want to talk about the differences between archiving and compression. So before we go into tar versus different types of compression algorithms, we need to talk about what an archive is. An archive is a single file that contains many separate files. These individual files can be extracted from the main archive. For example, if you're used to a backup, archiving could be one backup file. However, that backup file, when you expand into it, could be multiple files. Versus compression or compressed files, and that is where you have a single file that's compressed, meaning it will be smaller than the original size. We can combine these two so that we can have a single file that's made up of multiple smaller files, and we can compress that, and that's what we normally view as a zip. So in the Windows realm, a zip could be multiple files that are compressed. So one last thing is, before we move past this, when do you want to use either or? Remember, compression shrinks or compresses a file. Archiving takes multiple files and gives you just one. Instead of trying to send multiple files, we could archive so that we can send just one file. But let's say you have a bunch of Word documents. You can archive it, but it's going to be fairly large. If you archive and then compress it, you can actually get all those Word documents fairly smaller, and that way you can send just the one file that actually contains several Word documents. So now let's look at specifically different types of compression and zip. Okay, so now we have to move on to different algorithms for compression. We have gzip, bzip2, and zip. So gzip is GNU-zip, and of course it's a compression utility. It's designed to replace compress. bzip2 is a freely available, patent-free data compressor using Burroughs World algorithm, and it's typically compressed files to within 10 to 15% of the best available techniques. So what I've noticed is gzip and bzip, while both of them are very similar in functionality, both in compressing and decompressing, both in speeds, also in the compression algorithm, how close that they can actually compact files, they're both pretty similar. But bzip2 is, again, free and patent free. Lastly, you have zip, and zip is pretty standard. That's cross-platform for both Windows, Macs, and Linux machines. Zip is just a generic zip. So let's talk about tar a little bit. If we want to combine tar and compression, we could actually go to our command line with tar-cf. That will actually not so much compress, but this will combine our documents, all of our files that we need, into one tar file. So tar-cf will combine the files into one file. F has to be at the end because F will denote the different file names. Don't worry about this right this second. Here in a few minutes, we're going to jump into our terminal and we're going to show you examples of this. If we want to decompress our tar file, we will do tar-xf. So what happens if we want to do tar with some compression? Over here, you'll notice we have gzip and gunzip, or gunzip. This will compress it, this will decompress it. Same thing here, tar-zcf. Z will denote the appropriate algorithm. Here Z is for gzip. and it will use a tar. It will compress using gzip, C, compress, F will be the file names. And if we want to decompress or extract them or inflate them, depending on the wording that you want to use, would be using tar z xf. Because again, X is for extract, C is for compress. And once we're done, that file will have a name like file.tar.gz. If you're used to a Windows standard 8.3, it's a file name .3 letter for extension, we can shorten that to file.tgz. If you're interested in using gzip2, same thing here, tar-jz jcf. So the J is going to be replaced. So it won't be using Z, it'll be using J. So Z for gzip, that's pretty straightforward. But why G or J for bzip? No one knows. I've done a lot of research on that, and I cannot find a definitive answer of why J. B is already a flag, so we can't use B. So that's the closest to an answer I can get. And again, our file will be transferred to file.tar.bz2, or again, if you want that 8.3 standard, it'll be file.tb2. So without further ado, let's go ahead and jump back into our command line so we can see this in action. Alright, so I'm already in my terminal. I'm not sure what directory I am, so I'm going to do an ls. Alright, so I'm in my home directory. So I want to change directory to go to my documents. I want to do another ls to see what I have available. You'll see that I have got test1, test2, test3 as 3 test documents that I want to combine. So I'm going to do a tar -c because I want to compress them, F. The next part is how do we want to name it? I want to name this files.tar. What files do I want to include? I want to include test1, test2, and test3. So, by doing that, I combined test1, test2, and test3 into files.tar. And to make sure, I'm going to do another ls, and you'll see that files.tar is there and it exists. So I'm going to go ahead and open up my file manager. So through the GUI, I can see that files.tar does exist, and test 1, 2, and 3 are also do exist. So what I want to do is I want to simulate some type of damage. So I deleted test 1, test 2, test 3. So we have the tar file, files.tar, and that is all of the test 1, test 2, and test 3 that were just accidentally deleted. So let's verify that they're deleted by doing an ls. And you'll see that test 1, test 2, test 3 are not there. They're just the temporary files, hence the squiggly line. So let's do a tar hyphen xf files.tar. Remember, x should be extracting files.tar. Now let's do another ls to see if those files came back. And they did. Test 1, test 2, test 3. So that's the basics for tar for both compressing and extracting. Alright, so earlier, the F. The F here is kind of important. So I'm going to go ahead, I'm going to remove my files.tar. So it no longer exists. So I'm going to retar this, compress, F. This time I've separated C and F. F has to be at the end, and F is going to denote the name. The reason the F denotes the name is because tar was, again, cape archive, and the way those archives worked was the first command for the first syntax for the command always denoted the file name. So files.tar. And once you do that, we can again test 1, test 2, test 3, and it will compress them. So you can combine the C and F, or you can separate them out. But again, the F has to be at the end. Now remember, with tar, there is no compression. So we're going to do an ls minus L, and we have test 1, test 2, and test 3 combined for our files.tar. Again, no compression is there currently.
Generally, all the files.
Alright, so normally these would equal our tar file, but again, there has to be header, there's overhead, specifically header information, and they should equal out to our tar file. But because our test Word documents are so small, they're not quite. But if you're doing this with 3 test Word photos, or 3 photos, not Word documents, you're going to notice that they'll be more proportional.
We do.
What happens if we want to see what files are being extracted? So I'm doing ls. So we have our test 1, test 2, test 3. So I'm going to go ahead, I'm going to remove my test 1, test 2, and test 3. So again, they're not there anymore. Just our temporary files, which I'm going to go ahead and remove those as well. Test 1 squiggly line. Test 2 squiggly line. Test 3 squiggly line. That way it is just our files.tar. So I want to do tar hyphen extract x v for verbose and f, and I want to extract files.tar. The v will let you know what it's doing. It's showing that we're extracting test 1, test 2, and test 3. There we go. Alright, so now let's get into our compression. So we already did an ls, so we know it's just files.tar, test 1, test 2, and test 3. But what happens if we want to compress them? Let's use gzip first. So we're going to gzip files.tar. So no error, nothing was returned. So we're going to do an ls minus L. And you're going to notice that we have our files.tar.gz. And that is way smaller than our files.tar. Because again, it compressed all of them. So I'm going to do another ls. But you'll see that files.tar does not exist anymore. It's just now files.tar.gz. So let's go ahead and extract. So gunzip files.tar.gz. Another ls, and now it's returned to just our tar. When you do gzip, it will take the cape archive, the tar file, and it will compress it, adding the .gz into it. If we want to do bzip2, same thing. bzip2 files.tar. ls minus L. And again, you're going to notice that using bzip2, we were able to save 4 bits, as opposed to this guy. So in this example, bzip2 actually was a little bit more efficient in compressing them. And files.tar.bz2. So B unzip to the name of the file, unzipped it, and there it's back. So files.tar and our 3 test files. Alright, so what happens if we want to do this all in one? So actually, I'm going to clear my screen. So let's assume we want to tar and compress all at the exact same time. So we're going to tar, we're going to compress. Let's do verbose. I want to use gzip first, so I'm going to use Z. F again for file name, and we're going to call this files.tar.gz. And let's see if that works. I got ahead of myself, so we have to tell it what files to include. So we want to include file 1, file 2, sorry about that, that should actually be test 1, test 2, test 3. So tar, compress, verbose, using gzip, F will be for the file name. Those are the 3 things that we want to compress to. And we compress test 1, test 2, test 3. We're doing ls just to make sure. And here we have our files.tar.gz. So what happens if we want to use bzip2? So we're going to do the same thing. We're going to do tar-c for compress, v for verbose, j because that is the one for bzip2, f is for our name, so files.tar.bz2, and we're going to include test 1, test 2, test 3. And again, it compressed test 1, test 2, test 3, and all of them. Let's do an ls -l to make sure. And here we go. We have our tar, we have our tar.bzip2, and we have our tar.gzip. So we can take and we can run these commands together. So what happens is when you do the tar-cvjf, that j actually just calls bzip2 for it to do that. What if we want to verify by extracting? So let's go ahead and remove test 1, test 2, test 3. So they do not exist anymore. Let's go ahead and extract our bzip2 file first. So tar hyphen. Again, the flags don't really matter as long as F is at the end. So I want to extract verbose. I'm going to be using J because I want to do the bzip2. F for file name, files.tar.bz2. And it extracted those files. Let's do an ls -l to make sure. Lo and behold, they are there. Let's go ahead and remove them again. Test 1, test 2, test 3. Another ls to make sure. So now let's go and let's double check that our gzip will extract as well. So tar minus, again, the order doesn't really matter except F at the end. So Z for gzip, X for extract, V for verbose, F for file name, and this is files.tar.gz. It extracted test 1, test 2, test 3. Let's make sure. And they are back again. So that way we can show that the order for the flags for tar doesn't really matter as long as F is at the end. We can extract, we can compress, we can play with additional switches. Okay, so let's say we have a folder that we want to archive. So I'm going to go ahead and create a new folder. I'm going to call this folder 1. I'm going to put my tests 1, 2, and 3 in my folder 1. And again, through home, documents, folder 1, test 1, 2, and 3 are there. So I'm going to clear my screen. I'm going to do an ls to show that folder 1 does exist in my documents. So what I want to do is I want to see if the zipping program or these zipping algorithms will actually recursively zip files that are in a folder. So let's try. We're going to use gzip2 first. So tar-j. We want to compress verbose file. I want to call this one folder1.bzip2. And next we have to say what file or what folder we're going to include. So folder 1, hit enter. It took tar-jcvf, that's the name. It took that location, folder 1, and all sub-items in folder 1, test 2, test 3, test 1, and it combined them. And again, we can do an ls -l, and we can see that it did take our folder.bz2, and that is our newly created archive. An interesting thing to note is, look at the current size of folder 1, that's where our 3 test documents are, and our compressed folder 1 is 213 bits, versus earlier, each of these guys are those 3 same test documents. Look at their sizes. By compressing the folder with the 3 documents, our size increased just a little bit. Alright, so let's see if that holds true if we do the same thing for our gzip. So tar, z for gzip, c for compress, v for verbose, f for the folder name. So this time I'm going to call it folder1 dot gz. I'm going to include folder 1. And it actually included all of them. So I'm going to do an ls -l to make sure. And again, bzip2. Here is our gzip. Oh, but you notice, for the most part, bzip2 shows better compression. But in this example, gzip one with better compression. It's smaller. So again, these are going to have to get playing with. For the most part, bzip2 is going to be the better algorithm for compression. It's just occasionally gzip does win out. So how do we use that with zip? Alright, so let's see if we can do zip. So I'm going to go ahead and clear my screen. Now I want to practice on some zips. So I'm going to do my ls first. And we are going to notice that everything that we want is in folder 1. So change directory, folder 1. ls to make sure we have our 3 test documents, and yes we do. So zip. Can we just do folder zip.zip and test 1, test 2, test 3. And you'll see that we can do that. We don't have to give it any specific flags. Which from there, which probably means we can unzip them. Unzip folder zip.zip. I take that back. Let's do an ls so that we see folder zip. Let's remove test1, test2, test3. Another ls. So it's just folder.zip. Now let's go and unzip our folder zip.zip, and it will extract all of them. Let's do an ls to make sure, and sure enough, they are back. What happens if we try to zip a folder? So I'm going to go back to my documents, ls. So you'll notice that these are all just my bzip and gzip, and we have our folder 1. Can I zip? I'm going to call this folder zip.zip folder 1. So it will let me, but you'll notice that it did not add test 1, test 2, and test 3. Here's our folder .zip. Let's go ahead and unzip folder zip.zip. Oh, I think I misspelled it. Unzip folder. Oh, that's because I totally misspelled zip. I added an A for some reason. And you'll see that it just compressed the folder, not what's in the folder. So what we have to do is we have to zip minus lowercase r for recursive. And from there, we are going to say folder zip.zip, and then what we want to include. We want to include folder 1. Now you'll notice it's going to add everything in that folder, not just the folder itself. So we've looked at gzip, we looked at bzip2, and we looked at zip. And in general, that's what we need to know for our tars and our compressions. So I wanted to thank you guys.